You're watching The Code Guy, and in this, the fourth episode, we are going to talk about collection types. Two in particular, lists and tuples. A collection type is basically a way of storing multiple variables within another. So unlike an integer which can just store one value, we could store multiple integers in that collection. And there's various things you can do with those collections once you've got that data in them. So here I've defined two variables. One is a list, which is the square brackets, and I'm using strings in this one, comma separated. And then we're creating quantities, which is going to be a tuple, and this uses parentheses, and we're using integers, comma separated. Just because I'm using all the same data type here doesn't mean you have to. Here I'm creating a mixed list, which has a string, an integer, a boolean, and a float. And then I'm going to cast it into a tuple using the tuple casting command, so we can see it as a tuple as well. And then I'm creating an empty list and an empty tuple with square brackets and parentheses. So if we run this, we should see there's our shopping list, there's our tuple, there's our mixed list, you can see square brackets, and then our mixed tuple, parentheses, and then the type of this is list, and the type of this is tuple. We can also create an empty list with just using the list command, or the list function, and the same with tuple. You would very rarely ever want to create an empty tuple, and we'll get to why later. But for now, just know that you can create them that way. There is one other way of creating a tuple, which is just to do comma separated values. So if I did 1, 2, 3, 4, 5, and we can print that tuple, and there we'll get 1, 2, 3, 4, 5. All the collection types in Python share a common set of functionality. Lists and tuples are no different. So if we want to find out how many items are in something, we can just do length. So let's clear out this stuff because we don't need it anymore. And then I'm just going to do length of shopping list. And we're going to do length of quantities. And if we run that, you'll see we get 5 and 5. And those lists do contain 5 items each. Collection types are also subscriptable, and that means that every sort of value has a slot with an ID that you can then reference. And the way these slots sort of work is, let me just replace that with a comment I created earlier. So each slot in a collection starts at 0 and moves up by 1 as you go through the area. So pizza is at position 0, banana at position 1. And if we get rid of our length here, we can actually just go straight to that value by putting in 1 there and 1 there, and that should give us banana and 5. And it does. And we can do that for anything. Switch these to 0 and I'll get pizza and 1. On top of this, Python also gives everything a negative number. And that's from the end of the array. So the last thing in the array is -1, -2 for the second to last, -3 for the third to last. So if we look for shopping list -5, it will give us pizza. And if we look for quantities -1, we'll get the last item in the list, which is 2. So we should get pizza 2, and we do. Now there is another kind of thing you can do called slicing. And you can think of that of just taking your list or your tuple and slicing it into pieces. And the way we do slicing in Python is we do open square bracket and a colon. Before the colon is the start position we want to start at. After the colon is where we want to stop, but not including it. If we want to get the first 2 items from a list, we would look for 0 to 2. And if we run that, we get pizza, banana. And then for the rest of the week, we might want to buy the rest of our shopping list, so we just move that 2 over there. If you leave that blank, it'll go all the way to the end of the list. And there you go. We go all the way to the end, cheese, sausage, fizzy pop, from the second item. Now, if we left the beginning blank as well, we'd actually just get a copy of the full list, because it's from beginning to end. The other thing with slicing is you can specify an increment. So if we put a second colon, anything after the second colon is the increment. So I can say increment by 2 each time instead of 1, which is the default. And now you'll see it gets every other thing in the list. And we could even do every 3. Now, something you often want to do with collections is find out if something exists within them. So if I want to see if cheese exists in our list and our quantities, how would I do that? We could do if cheese in shopping list, print found. And if we run that, we get found. If we now change this to quantities, we shouldn't find it, and we don't. But if we change this to the number 12, we should. And of course, we can do this with a variable. So we could say is in equals, and then if we print is in, we should get true. And we do. Now you might want to find something and also know where in the collection it is. To do that, we can use something called index. So if we change this to shopping list.index cheese, we can see we found it at position 2. If we change this to lowercase c, we'll actually get an error, and that is that it couldn't find it. So if you use index, you will get an error. Do make sure it's in the list before you search for it. Otherwise, your program's going to crash. An index is also a thing on Tuples as well, so we can do index of 12 and change this to quantities, and we get position 3. Now, on top of that, all collections are iterable. What does that mean? It basically means we can go over each item programmatically. And to do that, we use a loop. In the ifs and loops episode, we talked about while loops, and we could absolutely do a while loop in here. So if we do index equals 0, and then do while, index is less than length of shopping list, we can now do print shopping list, and we need to remember to increment our index, otherwise it'll loop forever. With our plus equals 1, it's actually printed the full list multiple times, and we didn't want to do that. We wanted to actually do index here. It's printed them in the order in which we created them, and that is because both tuples and lists are ordered. Once you put something in them, they will stay in that order unless you deliberately change it. The problem with while loops in this scenario is it's a bit cumbersome. We've had to create an index, we have to go and pass it in. It's a nightmare. So we could simplify this. And that's where a new kind of loop comes in called the for loop. And what that allows us to do is if we do for item in shopping list, we can print item. So what the for loop does, it creates a variable called item for each item in shopping list. And it will loop through each item in the shopping list until it runs out. So if we do this, it should do exactly the same as our while loop, but with far less code. Quantities are obviously the number of each item I want for my shopping list. So how can I join those together so that I know what I'm buying with just our for loop? Well, we could recreate our index, which would allow us to reference the other object, but there's another way. We can actually use something called enumerate. And the enumerate function around an iterable basically creates a new tuple, giving the number of the index of each. So if we actually just print item for this enumerate, we can see that we get 0 and pizza, 1 and banana, 2 and cheese. So it's giving us the index location of each. And this will work the same way for our tuple. But what we can now do is we can print item, or we can print quantities, and we could do item 0, which is the index, and this would then be item 1. Because basically it's now a tuple in an iterable, and we get the numbers, and we should probably put an X in there just to make it clear we want multiples of them. And of course we can't mix strings and integers, so we're going to have to wrap this in a string to convert it. And there you go. I forgot my space. So that's done exactly what I wanted. And what we can do with tuples is we can actually dereference them. So I can do index item, and what this will do is it will split that tuple into 2. And then I can say string quantities index and item, because it's already dereferenced. I don't need to go to the individual points now. And that gives us the same result. Just as I mentioned, we can dereference that. We could also dereference quantities. So I could do A, B, C, D, E equals quantities. And then I can print A, B, C, D, E. And you'll see here 1, 5, 3, 12, 2. So with the tuple, it's actually dereferenced the tuple into these variables. And we can actually do the same with a list. Now this is where lists and tuples start to diverge. Lists have a lot more functionality. So why have 2 data types that are very similar but then one diverges? And that's down to something called mutability. In Python so far, all the variables we've looked at with the exception of the list have been what we call immutable. That means that once you create them, you can't actually change them. And you might think that's ludicrous because we had variables of like 1 in the first one and we added a number to it and we got 2. But what happened under the hood is a new variable called 2 got created and put in the place of 1. And that's because when you modify an immutable object, it creates a new copy under the hood for you. With lists, because they're mutable, we can change them in memory and keep a reference. And now this can cause its own unique problems. And just to prove what I mean about mutable versus immutable, just like we can grab a value, we can change a value. So if I do shopping list 1 equals apple, and then print the shopping list, that works fine. Banana has been replaced with apple. If we do this with quantities, we'll get an error. Type error, tuple object does not support item assignment. So tuples cannot be changed once they're created, lists can. So why would Python support immutable types if we get much more flexibility from mutable types? And there's a reason for that, and that is performance and cost. It costs a lot more to create lists than it does tuples, and it also costs a lot more to find things because lists are inherently more complex. So if we have a huge list and a huge tuple, we will actually notice a difference when we search for an item in both of them if they're identical. With our small ones, it's practically non-existent, the difference. You won't notice it. But as our constructs get bigger, you will definitely start to notice it. And so the general rule of thumb is, if you don't need to change something, then use a tuple, because it will be much, much quicker than using a list. But if you do need to change it, it's much easier to change an immutable object because you don't need to recreate one under the hood, you can just change it. So now, if we get rid of our quantities completely, because we're not going to use it anymore, I will show you how we can change some items. Now, I've already showed you that we could change banana to apple, but it's much deeper than that. So lists come with a load of built-in methods, one of which is remove. And we can remove banana, and now it's gone from the list. We can also do what's called appending. So I can add beer. And you'll see beer's appeared at the end of the list, and our banana is still gone. And we can append multiple things. So we could do wine as well. And each time you append, it just gets added to the end. Now, obviously, beer is very, very important. So one of the things we might want to do is put beer right at the front of our list. And lists allow us to do that using something called insertion. So we can do shopping list.insert, and then we give it the position. We're going to use 0 in this case, and we're going to add beer. And if we execute, there you can see beer is now at the front of the list and everything else has been shifted backwards in the list. Now just be wary of this. If you expect your list to be in a particular order, inserting is a very bad idea, so don't do it. Also, removing can also be really problematic. And I'll show you a bit about that later. The other thing we can do with the list is actually clear it. This would wipe everything out of the list. And you see we've now got an empty list. We can also ask it how many items are in with particular names. So I could do count of pizza. And then I can print counter, and there you go, 1. Now, if we had a second pizza, we should now get 2, and we do. Basically, all the comma does in a print is basically puts a space between the items we want to print. We can also specify a separator of comma, and that would separate them like that. I'm just doing that for ease, so I don't have to type print multiple times. Now, what would you do if we had 2 shopping lists and we wanted to merge them together? So let's say a friend of ours is much healthier than us and wants apples and pears. Could we use a pen for that? And let's have a look and see if we can. And it's kind of added it, but it's done something weird. And that is that it's actually added the list as a sublist to the list. And just as we can add tuples to lists, we can add list to lists as well. So if I do print shopping list -1, that'll give me the last item, and you'll find that that is actually a mini list. What I can also do within that is get me the first item, which will be pears. And we can actually go further than that because technically speaking, a string is a collection of characters. So if I want the second character of pears, I can do -1, 1, 1. And that will give me E from pears. So string is also a collection type. Now something else we can do with our lists, I mentioned they were sorted, we can resort them. So if we want to sort our list into alphabetical order, we can do shopping list.sort. And that will sort it in alphabetical order. And now banana, cheese, pizza, pizza, fizzy pop, sausage. There is a problem with that, in that that has changed the list in place. If I try and print shopping list.sort, we'll actually get none as the result. And that's because sort doesn't return anything, it just changes the list. If our program requires the list sorted for one thing, but needs to maintain the order for something else, you'll have a problem. So the way we can get around that is instead of using .sort, we can use sorted, the function, and that will do the same thing as list.sort, but it will sort it and return, leaving our list untouched. So here you see it's resorted our list, banana, cheese, pizza, pizza, fizzy pop, sausage, but our original list is still intact and in the correct order. So in general, use sorted if you ever may want to use that list in the right order again. To do with sorting, you might want to reverse a list order for whatever reason. Shopping list.reverse, and that will give us it in completely the opposite order. So we now got fizzy pop, sausage, cheese, banana, pizza. You should take a shot every time I say pizza. This video will become far more fun. You might not also remember it, so you might have to watch it twice. I do apologise. Okay, so what else can we do with lists? And what are the pitfalls of mutable objects? So if you remember from our first video on variables, we did A equals 1, B equals A, B equals 2, and then we can print A, B. And we had no issue. It kept the two variables. With mutable objects, this is very, very different. So if we say A equals shopping list, and then do a.append beer, you will see that our shopping list and value A are the same, i.e. we've changed both, and we didn't really want to do that. So if you are going to reference another object, but you want a copy of it and not the actual object, just do a blank slice. And now the two will stay separate. Notice that this also happens with functions. So if we write a super quick function, and we just, what are we going to do in here? We got a list, which is our variable, and we're going to do a list.append 1, and then return a list. And then what I can do is A equals add 1 shopping list. Now, surely that is not going to be the same value. So let's run it. And it's added 1 to both. So even if you pass a list to a function, it will mutate the object. One way around that is you can actually just copy it within the add 1, or you can copy it before you pass it in. I prefer to do it in the function, especially if that function is not supposed to touch it. So I would do a list and turn that to temp list, and then act on temp list instead. And if we run that, you'll now see that one has it and the other one doesn't. So that's fixed our problem. Anyway, going back to the adding two shopping lists together, and I deleted that reference. Let's try and reverse the code. Okay, to add two shopping lists together, we would do shopping list.extend, and then we'd do friend list, and then we can print shopping list. And there you go. It's put our two lists together in the same order they're in, one on the end of the other. Now, if we appended shopping list to friend list, it would be the other way around. You get apples, pears, pizza, banana. There is another way of doing this as well. You can do plus equals friend list. So the way we would append two strings, we can also append two lists. And this will give us exactly the same result. The one other thing I want to show you is something called pop. And what we can do with pop is take something off a list. So if I do shopping list.pop and print it, and actually before we print it, I'm actually going to say popped equals shopping list.pop and then print pop. And that's taken pizza off the end of the list and popped it. And we can actually pop multiple times. So if I pop twice, we should get pizza fizzy pop. So what it's done is it's turned our list into a last in, first out. And it just pops things off. If you didn't want to do that and you actually wanted to pop off the beginning of the queue, you can actually give an index of 0 and it will now pop from 0 upwards. So we should now get pizza banana. So we now get a first in, first out queue. Now pop can also be used in a list. And I'm going to show you one of the dangers first. So for item in shopping list.pop, print popped. Now this is going to give you some weird results that you're not going to expect. So we can see it's actually stopped after 3. So why is that? And that's because the list is mutating as we go. And we get to a point where we've removed items from the list, the system no longer knows where we are. So the way we can get around that is we could clone shopping list to A again, a copy of. Now both of these are identical, and then we could loop over A. And I'm going to use the underscore because we don't care about the result. And now if we loop over it, it's going to work because we have a fixed point of reference, which is A, which is a copy of the list to loop over, and they're the same size. If A was smaller, you would get less results. It would pop off less items. Now, the other way we could loop around this without having to create duplicate variables and everything is go back to our friend, the while loop. And what we do here is while shopping list, we can do popped print popped, and that will work. But how did that work? Because what made the list stop? And this is because if we do print and convert shopping list to a Boolean, we'll get true. But if we first shopping list.clear, we'll get false. And that's because when you cast a list to a Boolean, if it's empty, it will yield false. And if it's got something in it, it will yield true. So basically that says while the list is not empty, it's a really cheap way of saying length is not 0. And then we can just run through. If you're popping off lists, I would use a while loop until the list is empty rather than doing something like that. Lists and tuples open up a whole different world of opportunity now within Python. There's so much more we can do with collection types than we could with just variables on their own. In the next video, we're going to talk all about dictionaries, which is another collection type and my personal favourite because it's so damn fast. If you don't want to miss it, please do subscribe and switch on notifications so you know when I next publish. If you happen to be watching this late, then it will also be up in the top left now. And with that, thank you for watching, and I hope to see you on the next one.